All right, recording. Good. So let's just look at question, I think it's 14. Is it? Yeah. Oh, one more one small comment here. I saw you do this a few times. I just didn't write it down until question 14. So in question 14, right, and similar questions, when x equal to 2, you say equation 2 equals 0. This one not so accurate because this 2 is referring to this entire thing, right? So equal 0, okay, I'm not sure if, I don't usually see that. I don't think it's very accurate as well. You should instead say dy by dx equals 0, or something like sub dy by dx equals 0 into 2.
Hello.
Right? Okay. Yeah, then similarly for all the other questions,
Yeah.
right? But that's just notation. Okay, the idea is correct. Okay, moving on to the part 4. That's the one that is problematic. So what is the question asking? Let me just bring up the question. I sent you a rotated version, right? Is it? This one. Can you see? This question 14, right? This guy. Yeah, so for part 4, you want to find the minimum gradient of the curve and the value of x when the minimum gradient occurs. So what you need to understand is whenever you see minimum something or maximum something, they're asking you to find minimum point, maximum point. Clear? Okay. Then here, minimum point of what? Minimum point of gradient of the curve. What is gradient of the curve? You think of it as the gradient function of the curve. What is gradient function?
dy dx.
Yeah, so you must treat dy by dx as a function itself. So let me show you how to do it. Over here, think of f of x equals to dy by dx, which is just some algebraic expression, x involved, x squared x. Okay, then now what the question is really asking you to do is to minimize f of x. Does it make sense? Minimize f of x?
Okay.
Okay, so you just use that start. Let me show you how to do it. So f of x, which is your dy by dx, is equal to whatever you found, right? Then you want to minimize it. So just to, I realized I didn't get you to use this notation. Just to remind you again, f prime of x is also a derivative. Sorry, that was an equal sign. Not just dy by dx. Also, what is f prime of x? It means you d by dx of f, or df over dx. But wait, f is what? Or f of x is what? Maybe I should put f of x. F is what? dy by dx, right? So that means it's really just the second derivative. Okay, is that important? Not important, actually. Okay, second derivative, so what? Doesn't matter. Just get the answer. Differentiate the dy by dx, which you know is this guy. Okay, maybe I can substitute in
6x minus 18.
Exactly. Right, the constant differentiate, you get 0. Okay, then after that, you want to minimize. What do you do? For minimum point, set f prime of x equal to 0, right? Right, the dy by dx is just a different notation. Prime is just the same as the derivative. Okay, so as a result, you get 6x minus 18 equal to 0. Solve for x, you get what? 18 over 6, which is 3. Okay, does that answer the question already? Let's see. Find the minimum gradient, value of x. Okay, so we answer half of the question, value of x done. But now we need to find the minimum gradient itself. So what do you need to do? Remember, f of x is the gradient function. F of x is the gradient function. How to find that minimum gradient?
How?
What does gradient function mean? Like if I tell you it's a fried rice function, what does it mean? Fried rice function means you put in the ingredients for fried rice, it will produce a plate of fried rice for you. Then gradient function?
Then why do you find the second derivative?
Oh, second derivative, because here they are asking you to minimize the gradient. Minimize the gradient. So dy,
Is it
you,
sub x equal 3 back into the
into,
fx?
yes, correct, exactly, that's it.
Then the y is your answer.
Yes, no, y here is f of x. Don't confuse because
Oh.
we already resolved the y notation, right? We already used the y notation for the original function. Is it clear? Don't say y, say f of x, okay? Sub back into f of x. This is a different y already. If you want to call it a y, don't call it y, huh? This is different. This is dy by dx, okay? So sub x equal to 3 into f of x. So of course, this gives you f of 3, right? Which is 3 times 3 square minus 18 times 3 plus 24. What's this? Is it negative 3? Yeah, negative 3. Okay, so that's the minimum gradient.
So find minimum gradient is find second derivative of dy dx. Then set it to 0.
Wrong. Hey, you're phrasing wrong already. You said find the second derivative of what?
dy d. Oh, wait, no, I mean find the derivative of dy dx.
Correct.
Then
Yes.
set 0. Then find x. Then sub x equal
whatever you found, in this case 3.
Okay.
Back into what? Is it
Back
the original
into
y
fx.
or dy by dx or d2y?
Back into function x, fx, or
Which is which derivative?
the first.
Yes, correct, the first derivative. Okay. Understand? Whenever they say find the minimum of something, that means that you want to do you want to treat the happy face, this guy as the function. Then your goal is to use that star on the function. Apply that star, okay, whatever it's called, the procedure essentially just 3 steps. Number 1 is differentiate. Number 2 is equate it to 0. Number 3 is solve for x. All right. Okay. And okay, solve for x not enough. Still need to sub back in, get the y coordinate, so on. In this case, the y coordinate is not y anymore. It's f of x coordinate, which is the dy by dx coordinate. So what we have found here is actually 3 comma negative 3, which is actually x comma dy by dx, not y. Is this clear? 3 is the x, the negative 3 is dy dx.
Yeah.
Okay, good. Yeah, then that's all. Then here you made a careless mistake. Negative 2x squared, you need to multiply by a negative sign first. You see, positive x times positive 2x gives me positive 2x squared. But here originally was negative. You didn't change the inequality direction also. So confirm wrong. Okay?
Okay.
That's a careless mistake. Okay, good. Now we can move on. After 12C, of course, we must move on to 12.
Wait, can
no.
go back. Can go back first. Oh yeah, wait.
Which one? Oh, I want to copy. Wait. Is there something I did wrongly?
No, because Wait, can you explain this thing again?
Okay, yes. Wait, which step?
The how you tell is like more than or less than. Then you use this, right?
Yes.
Yeah.
I'll explain this part, the last step. Okay, how do you go from this second last line to the last line using this diagram?
Yeah.
Can. So after you already factorize it correctly and the inequality direction also correct, right hand side always 0. What does less than 0 refer to? Less than 0 means
less than
negative.
0 is just below the
negative,
like,
so must be
is this below. Okay,
correct. Then you must look at the corresponding shadow. This is like a bridge. Then there's a shadow, which is the x on the x-axis. Okay. Then you want the part, then you want the shadow as your answer, which is from -3/2 to +2. Do you put equal sign or don't put equal?
No.
Don't put. Why? Because strictly less than 0. So you don't put equal. If you put an equal, you're allowing for x to be exactly equal to 2, which will turn this into a equals to 0. No longer strictly less than 0. Oh, likewise for -3/2. Cannot have equal.
Okay.
Yeah, that's it. If you want, in terms of a graphical approach, this is the standard lazy way that students are taught, Sec 3, Sec 4 students are taught. But the correct way, what's really going on is you're drawing a graph of, let me just draw it nicely, -6, okay, something like this, not very accurate. There's a +2, there's a -3/2. This is the graph of y equals 2x squared minus x minus 6, which has been factorized as x minus 2 times 2x plus 3, right? Then when we tell you this one less than 0, what we are really asking you is, this is y. We want y less than 0. In other words, this graph is made up of all these tiny little points, right? They each have a x comma y, x comma y, x comma y. We're asking you which of these points have a y coordinate that is less than 0, negative y's. Clearly, it's these points here, right? And then we're not interested so much in the y now. After you identify the points, we want to find out the corresponding range of values of x that make up these points. And what are those x values? It's -3/2 less than x less than 2. This shadow here, right? And understand?
Yeah.
Okay, like give you extension question. What if instead I had something like a cubic curve? Let's say this is y equals to, I don't know, 4 times x minus 1 times x minus 7. So there is 0, 1, 7. I want 4x bracket x minus 1 bracket x minus 7 more than 0. What's your answer?
More than 0. Wait, hold up. I mean, okay.
Correct.
Would be.
So correct, you identified the correct region already. It's this part and this part. But you need the corresponding shadow. So maybe I'll just change a different color. Can zoom in. I hope you remember something from the trigonometry questions I gave you. It's the same idea.
Remember something.
From trigonometry, like you look at the graph, then I tell you more than 0. So what's the corresponding angles, corresponding radians at the bottom? This is the same idea. So look, this first part you identified. What's the shadow, the region?
0 and 1.
0 and 1. So you must always have an x, then 0, 1. Okay, from small to big. What's the connector in between? And or or? And or.
Or, because it cannot be. Wait. Or, and.
Wrong, it's or. Your first answer was correct. It should be or. Or is like union. You remember your sets. Set A, set B. A union B is the same as X in A or X in B. This notation on the right side probably you're not familiar, but the left side definitely familiar, right? A union B. Yes?
Yeah.
Or means what? Means you could be inside this part here, A only but not B, or the right side there, B only but not A, or you could be in the overlapping region here, A and B at the same time. Okay, so or actually here technically if you it's of course it's impossible for you to for x value to be both in between 0 and 1 and more than 7 at the same time. Yeah, correct. It's more than 7. I think you already got that. It's impossible for a number to be both less than 1 and more than 7 at the same time, right? So that means that actually what's really going on is this middle part, the purple overlap shouldn't be there. we should only have this right side. So you only have two possibilities. You're in A, but not B. You're in B, but not A. Where A refers to the possibility of X being, maybe I should write this down. All the X values in between 0 and 1, where in between means exclusive. Don't include 0, don't include 1. Then B will be all the X values more than 7, strictly. Oh, so what's really going on is actually we are only on the left side or the right side, but not both. So this is technically an exclusive OR. Exclusive OR. Have you heard of that phrase? Have you heard of that word?
Exclusive or
Ah,
no.
this one is something that's in the topic of Boolean logic. You can go and Google this. If you do programming, you'll
Isn't
learn
like
this.
the true and false thing?
Correct. Yes.
Oh,
Yeah. This is known. Technically, it's exclusive OR, but for all practical purposes, for exam, just put OR can already. Don't need exclusive OR. Okay, I'll just put an X there, and then yeah, I'll put in brackets. Okay. Can know how to read the graph already. When I ask you more than 0, you look at the part of the graph that has Y coordinates being more than 0, or think more simply above x-axis. Then you look at the corresponding shadow. So it's 0 to 1 for the left part and more than 7 for the right part. Okay. Can good. So inequalities done. Now finally, yes. Since we already start talking about what minimizing gradient and whatever, it's time to begin the next chapter. Actually, not really the chapter. It's just a simple application. You already are very familiar with Vesta. Now it's the application. Problems on maximum and minimum values. So this is the most powerful, this is the most practical thing you will learn from differentiation, which is to find the maximum or minimum of a function, right? Finding maximum point, finding minimum point. But now you must learn to read the question and convert from the English into a diagram, from the diagram into an equation. Once you have the equation, then you do Desta. So that's the difficult part. You must form the equation first, which requires Pythagoras theorem, mensuration, all the volume of a sphere, surface area of a sphere, all the fun stuff you learned before. Curve surface area of a cone, all those things you learn from EMAth. Must come back and haunt you. Okay, let's read this example. Okay, maximum area enclosed by a wire. So imagine you have a piece of wire of length 240 cm. Then you want to bend it into the following shape. Okay, maybe you're a farmer and you have some animals inside. Then you want to save money. You have 240 cm of wire only. You can only afford this much. So you want to make sure you can give as much room to the animals as possible with this limited amount of wire. Okay, if you can imagine that situation. So we want to express y in terms of x and show that the area a cm square enclosed by the wire, like this region that the farm animals are going to be inside, is given by a equals 2880x minus 540x squared. So that's the first part. Then the second part is, after you found that formula, show that formula is true. Part 2, you want to find the value of x and of y for which a is maximum. Hence, find the maximum area. So there's sort of like 3 parts in one question. Hence. What does hence mean? Hence means what?
Like, hence? What does hence mean? Using part 2. Wow,
correct, yes, exactly. That's all I wanted. Yeah, use the answer from part 2. Okay, don't start from scratch. Some students, they see it, hence what, nothing comes to their mind. They redo the question from part 1 and part 2 for me again. Then they start to answer part 3. Wrong. Please use the answer from part 2. Okay? Yeah. Okay, let's just read the question. So lucky for you, this question, they gave you the diagram already. So all you need to do is to figure out how to find the area. Also, actually, by the way, part 1 usually in university, they won't give you this kind of formula already. They'll just ask you, find a formula for A, maximize the area. They won't even tell you the formula. So this question is being kind to you. They give you the formula. So you can imagine during exam, you don't know how to do part 1. Like they are asking you to show, you need to prove. You don't know how to show it. But it's okay. You can still do part 2 and part 3. It's just that stuff. You want to maximize the area, right? Differentiate, equals 0, solve for x, sub in the x, get the y. In this case, it's capital A. Yeah. Then you can eventually get the maximum area. Okay, but let's just look at the diagram first. So first, I hope you can see that there's a triangle. And what kind of triangle is this? Two sides
What
equal.
kind of isosceles?
Isosceles triangle. Okay, good. And what shape is this here at the bottom?
Rectangle.
Rectangle. Okay, so a rectangle, I'm sure you know, opposite sides equal length. How to find area? Length times breadth. Then how about a triangle? How to find area of triangle? Half times.
Half times base times height.
So that means you must imagine on your own. There's a base here, there's a height
24x.
here. They never draw for you.
Base,
you must imagine. Correct.
Base
Good.
24x. Then you split into half both x each side. Then you use Pythagoras theorem. Then you find height.
Correct. Yes, you have to split half because by symmetry, you can see these two lengths are equal. Okay, so let's just look at the solution. How did they do it? So 24x here, so you can split half. So 12x, 12x. And over here, you get a right angled triangle. Just draw the diagram and label a M for me. Please draw a diagram. Must get used to drawing diagram. Okay, engineer, you cannot not draw diagrams. Must know how to draw diagrams. Okay, right angled triangle here. You got 12x, you got 13x. Then how to find AM? Just use Pythagoras theorem. So that's what they did over here. 13x bracket square equals 12x bracket square plus AM square. Make sure you got the brackets around the 13x and 12x. Okay, so 13x square will become 13 square x square, which is 169 x square. Then 12x square will become 12 square x square, which is 144 x square. But you have to bring this over so you have a minus sign. Like terms, both are x square, so you can combine into 25x square. Then to find AM, you just take the square root, you get 5x. Okay, so let's label over there 5x. Okay, not done yet. So what else we know? We know that the perimeter of this shape, here, you know what's perimeter, right? Yeah, the outer region. Just take a highlighter and highlight it if you need to. Then this will be the perimeter, which is really just the length of the wire, 240 cm, right? Okay, you just imagine a situation where you use up all 240 cm, there's nothing left over. All right, so that means that something is equal to 240, the perimeter is equal to 240. Then what's the perimeter? Just add each of these lengths together one by one. Opposite sides are equal in a rectangle, so y and y. And this side, by symmetry, it must be a 13x as well. Actually, you don't even need symmetry, it's given. Right, I'm just transferring the diagram, the labeling over. So what we end up with is 13x plus 13x plus y plus 24x equals 240. Then from there, you can solve for y. You get 120 minus 25x. Maybe I just do some working here. 26x, 2y, 24x, 240. 26 plus 24 is 50. So we get 2y plus 50x equals 240. You can divide by 2. So y plus 25x equals 120. And bring the 25x over and we get what we have here. Okay so far?
Yeah.
Not enough because they're asking for area. We are still not done yet. Also, by the way, area here, you notice that it's all in terms of what letter?
X.
But if you want to find the area, you see it's really just finding area of triangle plus area of rectangle. But area of rectangle, length times breadth, you see y and 24x. Then that will be a problem, right? There will be an extra letter y. We don't want y in our final answer. So that's why that's why they had to introduce this step here for the perimeter. You have a formula for y in terms of x. Then you can just replace it with 120 minus 25x and find the area, length times breadth, so on and so forth. So let's just see how they do it. So for area enclosed by the wire, they tell you it's area of the triangle on top plus the area of the rectangle below. Okay, then they use the letter capital A to represent area enclosed because that's the letter that was used in the question. Please use the letter that was used in the question now. Don't come up with your own symbol. Follow the question. Okay, over here. Then area of the triangle is half times length times half times base times height. So half times 24x times 5x, right? Base 24x here. And the height is 5x. Okay. Then area of rectangle BCD will be length times breadth. So 24x times y. 24x times y. But we don't want y. We only want x in our final answer. So we replace the y with 120 minus 25x. So that's what we do over here. Then simplify half times 24 times 5 is just 60. And everything else you expand and you simplify, you end up with whatever they wanted. Bracket shown. Okay so far?
Yeah.
Good. Now let's look at part 2. Part 2 says find the value of x and of y for which a is a maximum. So just ignore the y part first. Focus on the x. What does this mean? A is a maximum.
A is a maximum.
Means maximum point.
Or
Then what is the procedure? What's the mnemonic I gave you?
delta.
Delta. What does it stand for?
Differentiate set to 0.
Equate to 0. Okay, correct.
Oh.
Same
Then
thing.
table.
S. What's S?
Wait, delta or set
You
to
equal-
0.
No. Equate or set. I usually use the word set. But no.
Oh.
S is solve for x. You equate to 0, of course you solve for x. I think you already will do that automatically. And then table. Yes. It's also known as the first derivative test. By the way, I noticed you haven't practiced using second derivative test. You should practice, you should try, huh? Although it's not 100%, but you still should know how to use it. Like what's the conclusion? More than 0, if you get second derivative, let's say you got a stationary point that's like a comma b, then you have to substitute x equals to a, and let's say you get more than 0. What does it mean about a comma b? Max or min?
Max.
Wrong, min. Hey, maximum? Let me think. Gradient. I mean tangent line with different gradient. Positive, 0, negative. Positive, 0, negative is decreasing. Decreasing, what is decreasing? The gradient function is decreasing. So this dy by dx is a gradient function, is decreasing. So d by dx is less than 0. This is maximum point. Maximum point, you have this picture. Tangent. Positive gradient, 0 gradient, negative gradient. Just write it in a fancy way like this to see the decreasing pattern. So what is decreasing? The gradient is decreasing. Decreasing means decreasing function, which means derivative will be less than 0. Wait, what's this thing in the middle? The gradient function. The gradient is decreasing. So the first derivative of that function is less than 0 for maximum point. But of course, that's just the second derivative, less than 0. So that means maximum is less than 0. So more than 0 must be minimum, the opposite. Make sense? So please don't, your first answer was maximum, wrong. Don't think more than max, wrong. Opposite, think opposite. More than minimum. And of course, let me just write down the other one to remind you. d2y by dx squared, substitute x equals to a, where a is the x coordinate of the stationary point, is less than 0, implies a comma b is a maximum point. Oh yeah, just an extra point to take note of. Only for A max, secondary school A max, then you just have to substitute x equal to a. In the future, when you're dealing with more complicated derivatives, you also need to substitute y equals to b. Or in H2 max.
Oh
For
my
now,
god.
don't worry about the b. Just throw away the b. Actually, it makes more sense in the future. Right? If you have a point, of course, you want to substitute every information you have. How come this one you have to specifically choose only the x and toss away the y? That's a bit weird. Like, don't you find that a bit weird? Like, it's sort of like an extra step you need to remember. Oh, ignore the y. So actually, in the future, I think it will be easier to remember the procedure. But never mind, for now, just remember only sub the x. Okay? And anyways, you differentiate with respect to x, the expression only have x. So of course you just sub x. Yeah, back to the question. Yeah, so part 2, find the value of x. Ignore the y first. For which a is maximum, it's just really asking you to use that star. So we proceed to do that star, differentiate, and you get this expression, right? For maximum or minimum, you equate to 0. Oh, here why they say or minimum? I thought the question already said find maximum. That's because it's a theory. The theory says that a can be either maximum point or minimum point or just stationary point. Then dA by dx equal to 0. We don't know whether it is maximum or minimum yet with this theory when we solve for x in this equation. So never mind, we just follow the procedure, equate to 0, solve for x, 2/3, substitute the x back into a formula for y, which we had previously over here, 120 minus 25x, 120 minus 25 times 2/3, which will end up with 53 1/3. Okay. Then now we need to figure out with x comma y, this y here, is it the area already? Yes or no?
Is it the y?
Area. Is y the area?
No.
Yeah, definitely not. Yeah, of course. Y is just the breadth of this rectangle. It's not the entire area yet. Okay, just take note. So don't be confused between the y and the area, capital A. Capital A, the formula is over here. Area, the formula for y is over there. There are different formulas. Okay, just take note of that. I'm sure you know that. Okay, moving on. So now how do you tell that this at x equals 2/3, we will obtain a maximum for the area? What we do is we have to do second derivative test or first derivative test table. Here, they decided to use second derivative test. If you presented your working nicely, you can recover your first derivative over here, which is 2880 minus 1080x, or actually over here as well. Then to find second derivative is just one line, right? I mean, it's just one number. Isn't that very convenient?
Okay.
Yes, right? You don't even need to substitute x equal to 2/3 here because the derivative is so simple. It's just a constant. You try to sub in x equal to 2/3, it still remains as the constant negative 1080. So now this guy is less than 0, negative. Then you can conclude A is a maximum. Okay. So last step, y is not the area yet. We still need to sub in x into the formula for the area, which is 2880x minus 540x squared. And then finally, we get our answer for area. Can? This is part 3. This one is part A. Actually, I can't remember the parts. Until here, this one is part 2. Okay, then the first part was part 1. Okay. Can now practice. Everything is just very similar. It's just practice. In the future, the question will get more difficult because I will need to introduce to you how to differentiate other types of functions. Since I got space here, I'm just gonna squeeze it in here. LIAT. Do you know what is LIAT?
No.
Okay, I'll write it down for you. L stands for logarithm. I stands for inverse trigo functions. You don't need to know this yet. This is H2 max, but the rest you need to know. A is for algebraic functions. Sorry, I should make it an adjective. IC. Trigonometrical. Then T is for trigo expressions. Then E is for exponential. You know 4 of these functions, right? Logarithm is like what? Log x base 2, that kind of thing, right? Then algebraic would be something like y equals 1 over x squared plus 2, that kind of thing. or you can have square root x on top. Make your life difficult if you want to differentiate quotient rule, right? And trigo, you already know sine, cosine, tangent. Oh. And then exponential, of course, you know, you did all the drawing of the graphs, right? Exponential graph, population of a rabbit, in population of whatever animals, population of bacteria. You remember those kind of questions? Yeah. So this is actually a list of all of the functions you need to know. And so far I have only taught you how to differentiate algebraic. You still need to learn this one, and this one, right? Okay, sine, cosine, actually I teach you before, it's a square, if you remember. Sine differentiate, you get cosine, cosine differentiate, you get negative sine, so on. Do you remember that?
Okay.
Okay, I will go through again later. If I want to go through. If not, I cannot assign homework. After this, I will go. Okay, so one more thing is inverse trigonometrical functions. It's referring to sine inverse x, cosine inverse x, and tangent inverse x. These functions you can differentiate them, but that's for H2 max. Okay, this is for H2 max. So I will not go through. Okay, I will not go through. I'll just focus on the first four later. Back to this topic. Let's just go through some of the questions for practice. Let me see. Oh, give me a second. Okay. I want to transfer it over to new worksheet. Okay, I'll copy it. What else is there? Okay, let's practice some questions. I think the first two questions should be quite okay. I think I'll go through question 2 first. Yeah, let's take a look. Okay, let's take a look at this exercise 12D question 2. So find the minimum value of the sum of a positive number and its reciprocal. So whenever you see the word sum, you must think it's a plus sign. When you see a positive number, you don't know what it is, then let x be the positive number. Then its reciprocal, its refers to x,
1 over
reciprocal
x.
means 1 over x. So must translate from the English sentence into a equation. It's really asking you x plus 1 over x, find the minimum. To summarize the question, this is all they're asking you to do. One more condition, and given that x is more than 0, positive. Yes. So what you should do is say let x be the positive number. Okay, so then you can say let f of x. Oh, you want y? Okay, y also works. Y also works. Because x plus 1 over x. Then you differentiate it. Okay, carry on. Yep. Find the minimum. So for SP, for stationary points.
Okay.
For SPs. Just use the short form. Wait. -2, not power positive 2. 1 minus x power -2. Yeah. Good.
Wait, 1 over x squared equals to 1.
Yep.
So x squared equals to 1.
Yep.
X squared equal 1. No, x equal to plus minus 1.
What did they tell you about x? Sum of
Reject
all?
minus 1.
Yes, exactly. So the answer is 1.
Oh, just 1.
Yep, because reject negative, so just 1. You have to say reject negative 1.
Okay, now x equal to 1. Sub x equal to 1 into equation triangle.
Yep.
Then
I just said 1 plus 1 over 1. 2. Yes.
y equal to 2. So now y equal to 2.
Yeah. So that is the minimum value already. Just to be.
Wait, this is the
actually,
minimum. Wait, this is the answer.
Sorry. Yes, this is the value, but to confirm that it is a minimum, you still need to do the test. Either first derivative test or second derivative test. Okay?
Okay.
I'm just taking screenshot for you.
X sine of.
Hey, try. I know you know how to do first derivative test already. How about you try second derivative test?
No.
Okay. Why don't? Practice.
No,
Practice. Yeah. One.
Okay. D.
The 2y. The 2 is in between the d and the y.
Oh my god. Okay.
d2y by dx squared. The 2 is move on top of it. Superscript. Yeah. Good.
Yeah. Then is 2x minus 3.
Yep.
Sub x equals
1.
1 into equation smile. Then you get.
Another way is you can say d2y by dx squared vertical line x equal 1. Then you got fewer words to write. Fewer words to write. Lazy way.
Okay. It's too late.
Okay, never mind. It's perfectly fine. Yours is a full form, very clear. Yeah, then you get 1/4, which is
more than 0. So
can you help me
more than 0 means it's minimum point.
Yes, which is answering the question, minimum. So confirm it is minimum. So you should write equals 1/4 more than 0. Just write in one line. I mean, equals 1/4 like this. Can you see what I wrote over here?
Oh, okay. Yeah.
Yeah, include this. Okay, I'll just take a screenshot, then you can copy it down if you want. I'll just look at a photo. Okay, send. Okay, done. Easy question. Oh, you want to go through the logic? How it's a minimum point?
Wait, do I have to know the logic, or like can I just like remember it as like opposite of like if it's more than 0, that means it's minimum.
For exam purposes, you don't really need to know the reason.
Oh, okay, cool.
Yeah, but
okay, then I like second derivative test.
Yeah, it's very fast. The only problem is when it's equal to 0. So what can you conclude from equal to 0? D2y by dx squared.
Inflection point.
Wrong. No. Hiya.
Wait, do first derivative test.
Yes, that's what you should do instead. But what can you conclude when d2y by dx squared equal to 0? 2 weeks, forget already. I write in big font, so big color, red color, cannot remember. What's the conclusion?
Oh, no.
No conclusion. Do not say it's inflection point. I gave you the counter example already. This is y got x power 4. We get second derivative is okay. We did first derivative test to confirm it is a minimum point. Then second derivative test, we realize that you try to sub in, you get 0. Answer is no conclusion. And yes, you're correct. You should, after you realize it's no conclusion, you should do first derivative test and conclude minimum point. Okay, remember, equals 0, no conclusion. Clear? Okay, very good. Okay, where were we? Just try more questions. Okay, time for the area questions, like question 3. Now another farmer. Applications in agriculture or something. There is a rectangular field. It is surrounded by a fence on 3 sides. What? Fence on 3 of its sides, and a straight hedge on the 4th side. So just think of it as a wall. It's just a wall. So basically, you get to have a discount. You don't need to use so much rope to form all 4 sides of the rectangle. You just need to use rope for 3 sides of the rectangle. This one comes for free because it's a wall. Does it make sense? So the farmer can save money. Okay, don't need to use so much rope. Anyways, if the length of the fence is 320 meters, find the maximum area of the field enclosed. So what's the length equal to? So let's say let L meters be the length. Actually, no, sorry. You don't need that. It's not necessary. Just use the English word length of fence. We know it's equal to 320 meters, but what's a formula we can form regarding 320? Wrong. No. Hedge comes for free. The wall comes for free.
Oh,
so you don't need rope
plus L.
Yes, correct. Just 2b plus L. Okay, good. Please be careful of this kind of thing. The wall they draw for you so nicely is to remind you, don't include the wall. You don't need to use rope for the wall. Okay, so with this, you can leave some space here. We will figure out, do we want to make L the subject or B the subject? We will see later. So we want to find the maximum area, right? So let's let A meters be the area. Sorry for the handwriting. A is then equals to what? Length times breadth, right? So L times B.
But then, okay.
So you got 2 different variables here. Can we deal with 2 different variables on the right side? No, cannot. I never teach you. That one is multivariable calculus. No. Can only have 1 type of variable on the right side. So here we must substitute
Make
L
subject.
No. Sorry, the first one. Yes, correct. Make L the subject. 320 minus 2b. Then you substitute in, which will allow you to convert this capital A to be a single variable equation. Only 1 letter on the right side. B. Right? Is that enough? No, we want to find maximum, right? So that's star. Differentiate. dA by d. What's the letter at the bottom? Is it x? Is it times t? B, okay, db. Don't go db. Okay. 320 minus 2b squared becomes 2b and 4b. All right. Next one, equate to 0. So for SP, stationary point. Stationary point can be maximum, minimum, or inflection point. We don't know yet. So we need to do first derivative test later or second derivative test to figure out. This equal to 0, which implies 320 minus 4b equal to 0. Solve for b, we get 320 over 4. Is the algebra okay? Can I'm going a bit fast. Make B your subject. Can Yes, no? Okay, can. Okay, then equals 80. Good. So now we get B equals to 80, then we find the maximum area. So area formula is over here. We got B is 80. What do you want to do? Do you want to solve for L or solve for A? Okay, you got two formulas involving B. Which one? Which one do you sub into? One or two?
You sub into
Equation 2. Right? Because you are looking for the maximum area. So don't need to find L. Okay. They never ask you to find L. If they did, then you need to do it. Previously in the example, they asked you to find Y, which is a bit extra. You don't actually need to find Y to answer the maximum area question. This is a bit extra. I found it a bit weird when I saw it. Yeah. So I told you to ignore it first, right? Because all you need to find the area formula is just the X. You solve for X, you sub in, you get the area. Okay. Same thing here. Just find the B, sub in, and you get the area. Don't bother finding the other letter, which is L. Okay, anyways, sub. I don't want to write so many words. So sub B equals to 80 into the area A formula. So I can write A vertical line B equals 80. This is perfectly fine. Lazy notation. Okay, sub in, and I need a calculator for this. One, 2, 800. Luckily, they never play around with the units. Everything is in meters, so we don't have to worry. Okay, so that's the answer for maximum area. But how do you know for sure it is maximum? This dA by dB equals 0 only works. It works for three possibilities: maximum area, minimum area, or a point of inflection. So how we must move on to the TA of the delta through the table method, right? So what do we do? Actually, since you already know how to do first derivative test the table, I'll just do second derivative test instead. And it's a lot simpler, right? This time, instead of dA by dB, you find d2a by dB squared, which is what? -4, right? Less than 0. So conclusion is max or min?
it is a max point.
Maximum area. Okay, less than 0, maximum, opposite. Easy? Yes, right. Quite easy, right? You already know that style. Now this is the only difficult part is the front part. You know already. Confirm all 15 questions were correct. Just need to practice second derivative test. It's quite simple, right? Just one more derivative. Less than 0, maximum, more than 0, minimum. Okay, let's try more difficult questions. I think the rest are all pretty okay. Yes, this one. I got sector. Rectangular box and what's this? Hemisphere. Some silo, SILO, to keep the greens or something. I think you can work out what's the volume, what's the area on your own. Let's try this question. A wire of length 80 cm. This is question 5. A wire of length 80 cm is bent to form a sector OAB of a circle. A sector is like a slice of pizza or a slice of watermelon. If OA equals to RCM and angle AOB equals to theta radians, express theta in terms of R and show that the area of the sector ACM square is given by A equals to half R times 80 minus 2R. Hence, find the maximum area of the sector as R varies. So what's the area of a sector again? Let's use capital A, right? They used it here. What's the formula?
Theta over 360 times pi r square.
That's the first version. What's the second version?
Or the
So
one
it's
in
theta in
radians.
degrees. For
Oh,
radians
I
one.
don't know.
Yeah, this one must remember half r square theta. Okay, half r square theta. That's it. Where theta is in radians. Okay, the r square theta. So you look carefully at what they are asking for. Half r at minus 2r. Half r square theta. You can see that they're very similar, right? Maybe if I write it as half r theta, then it becomes more obvious. Half r is the same. At minus 2r, r theta is different. So that must mean they must be the same. At minus 2r must be the same as r theta. Yes? But how do you know that? That's when you need to know another formula of from the radians topic. Theta equals to what over what? Theta equals to
Theta equals to
S over R. Don't remember. E-math. This one E-math.
S over R.
The curvy part of the pizza, also known as the arc length S, divided by the radius. Forget already. Oh no. Arc length divided by radius, S over R. Okay, so anyways, what we should do is to start off by knowing that, area equals to half R squared theta, but then we know that theta is S over R, right? So that means that instead of writing this, I will write down half R squared times S over R. But instead of writing S, I need to figure out what is the value of S in this case. In this case, S is referring to the curvy part of the pizza. In other words, arc length of AB, right? So now our goal is to figure out what is S. S is really just arc AB. Then you must read the question again. What did they tell you? First sentence. Are you reading? So what's arc AB? Is it
arc AB?
The length of arc AB.
80. Wait, is it 80?
Is it 80?
I don't know. Is 80 the whole thing or just AB? I honestly cannot tell.
The whole thing. It's the whole thing.
Oh, okay.
80 cm is bent to form a sector, means you use all 80 to get the entire pizza. So here, here, and here, 3 different parts. But of course, you can see that this length here and there is R and R. So that means the remaining part must be total minus away the ones you don't want. So 80 minus 2R. Is that okay? Can? Then as a result, you can fill in the blank here. 80 minus 2R. Arc length divided by radius. Then of course the radius and radius can cancel away. One copy. You're left with whatever they wanted. Half R 80 minus 2R. Clear? Shown. Ask you to show, then you shown. Answer back the question. So if you cannot solve this first part, never mind. They gave you the formula here already, then you can at least answer the second half of the question. Hence, find the maximum area of the sector as R varies. So again, test star. Or don't use table, use second derivative test faster. So let's just proceed to do that. So A equals to half R times 80 minus 2R. I don't want to use product rule, so I'm just gonna expand this. I'll get 80R minus 2R squared. So dA by dr will be half factor out, differentiate term by term. So 80R, you get 80 minus 2R squared, you get minus 4R. Okay, then after that, you say for SP, you set dA by dr or equate dA by dr equal to 0. which will give you half times of 80 minus 4r equals to 0. The half and 0 can cancel away. You get another 0 times 2 on both sides. Then you end up with r equals to 20, right? What else? Not enough to just say r equal to 20. You need to find the corresponding area when r equals to 20, right? To find the maximum area. So what do you need to do? You have to substitute the r equals 20 into the formula for a. So half times 80 times 20 minus 2 times 20 squared. What is this? I need a calculator. Let's see, 80 times 20 minus 2 times 20 squared. So you end up with a 400 cm squared or meter squared. I think it's cm squared, yeah. Okay, but this is area. We don't know for sure whether it is maximum or minimum or a stationary point of inflection. So that's when we need to do the second derivative test. So d2a by dr squared, what do you get? Half factor out, 80 becomes a 0, minus 4r becomes minus 4. Right? Then you get negative 2, which is less than 0. This implies that a is a maximum. Done. Is it clear? Okay, good. Moving on. Let me know if you need me to slow down or anything. Let's try open tank. Okay. An open tank with a square base. Actually, yeah, I'll just start a new page. Question 8. An open tank with a square base is to be made from a thin sheet of metal. Okay, so what's an open tank? Draw an open tank. Draw 2 rectangles, join the lines. Open means that there is no lid here. This top part is empty. Okay? Okay, top part is empty. No lid. To be made from a thin sheet of metal. Okay, find the length of the square base. I draw wrongly already. It's a square base. Let me I redraw. If not, it's confusing. Okay, roughly a square like this. Okay, close enough. No lid. Right, it's a square base and the height of the tank, so that the least amount of metal is used to make a tank with a capacity of 8 cubic meters. So I like to label a few things whenever you have a diagram drawn. They want length, so I'll use L, 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 L. Okay, 4 sides of a square. Length of the square base. And you have height of the tank, so H for height. We'll label like this, H. Is that okay? Very good. So what is the capacity? Capacity just means volume, right? So what's the formula in terms of L and H? Base area square, L square
H.
Times H. Yes, L square H. But that is the volume, right? So I would like to call capital V equals to L square H. Is that okay?
Okay.
Can? What do they want? They want the least amount of metal used to make a tank with a capacity of 8 cubic meters. So what is our objective here? To minimize the amount of metal, correct? Yes?
Yeah.
So maybe, so you must remember the objective here. Objective here is, let's write it in English first. Minimize the amount of metal, sorry. Then after that, you must look at your diagram and think, which parts of this is being used to make the, is the metal occupying? Are we making a cuboid shaped block of metal? No, right? We're making an open tank. So what it really means is we only care about the area that is occupied by the metal. Does that make sense?
Okay.
This is also the same as saying minimize the area occupied by the metal. Just ignore the fact that the metal is supposed to have a certain thickness, which means that it's a volume. But we're just gonna pretend that it's only like 1 millimeter thick, so we don't have to care about how thick it is. We only care about the area occupied by the metal, and we want to minimize it. Okay, so what is the area? That's when you must look at this shape and figure out, how to find area. Oh, you remember, you need to draw a net. Do you remember the idea of a net?
Oh my god.
So since this is open, do we have 2 squares or 1 square? Is it 2 squares or is it only 1 square?
There's only 1 square.
Yes, very good. There's only one, because there is no lid. No lid, so there shouldn't be a square at the bottom. And when we want to minimize the area, what we are really asking you to do is, first step, find the area occupied by this net. Then after that, do the star on the area. So what's a good letter to represent area? What's a good letter?
A.
A. Do you use small letter A or capital A?
Use capital A, I guess.
Use capital A. Yes, please do that. Let me get my charger. Sorry. Okay. Sorry. Yes, please use a capital letter A for the dependent variable on the left side. So we need to figure out a formula for the area. So let's see. I believe this square area is L square. How about the area of this rectangle? What's the area of this rectangle?
The LH.
LH. Then of course all the other rectangles will also be LH.
LH, yeah.
So it's just L square plus
4
4 times
LH.
LH. Very good. Now, wow, very complicated. You got L, you got H, two types of variables. That's not good. What did they tell us?
One subject.
Correct. So we need to make use of values that are in the question. Wow, so many variables. If only there was a number we could use. Do you see a number in the question?
Do I see a number in the question?
I see so many English words. The only number
capacity
here,
8. Volume is 8.
So this equals to 8. Then how? How to continue?
H equals to.
Yes, correct. And therefore H equals to 8 over L square. If you try to make L the subject, what problems will you encounter?
You square root, then you get 1 negative, 1 positive.
But here, of course, L is a length, so don't need negative. So L will be square root 8 over H. This will also work, but you see, here got L square, here got L, so you have to substitute 2 times. Then you need to do more work. It will work, but you can make things in terms of H, but you will have more algebra to do. Okay, so be smart here. You have L square, you have L, you only got 1 single H. Then just make H a subject and sub in. Easier. Make sense? Strategic exam strategy, not so important. I mean, I think your algebra is strong enough. Anyways, H is now 8 over L square, then you can just sub in with 8 over L square. Maybe I'll just write down here, sub H equals 8 over L square. So 1 copy of L cancels away. L square plus 4 times 8 is 32 over L. Can? Very good. Then testa. Can I leave this as an exercise to you? I think you know how to do, right?
Yeah.
Just dA by, okay, so what am I supposed to find? First derivative, d what over dy?
dA over dL.
Very good. Yes, don't always y over x. A over L must adapt to the question. Okay, dependent variable here always at the top. The independent variable is on the bottom. Equals . Then after that, you just solve for L. sub the L back into the formula for A, you get the area. Is it maximum, minimum, or inflection point? You have to do a first derivative test or second derivative test. And then you conclude, oh, this is a maximum, oh, sorry, so this is a minimum area because least amount. Huh? They designed the question so that guaranteed after you do first derivative test or second derivative test, you will conclude that it is a minimum. Okay, I'll leave it as an exercise to you. Is that okay? I'm sure you know. You already did 15 questions on this. I'm sure you know how to do testa. The only difficult part is the front part. Okay, let's try more examples. Let's see. Yellow, try already. Spherical. Okay. Time to try some spheres. Cover all the shapes. Cover rectangle, sector. Haven't covered. Cover cuboid already. But not really. I covered area. I didn't cover volume. Maybe I should go through question 4. And this one is volume of a sphere. Okay, I'll try question 4 first. Later, then try question 9. Okay, let's go. So question 4, a rectangular box has a square base of side x cm. So again, another square base x. Wow, this one is not very nice. Let me try and draw it nicely. Okay, a bit nicer. Square base x cm. If the sum of one side of the square and the height is 15 cm, where's height? I cannot see height. Then I label myself. Come up with your own label, H. What does sum here refer to? Sum. Plus, minus, times, or divide? Must be a
Plus.
So sum of what and what? One side of the square. So that's a x plus h equals to, what's the only number you see? Right, Tess, can you hear me?
The only number I see is 15.
The sum of one side of the square and the height is 15 cm. So x plus h equals to 15.
X plus 15.
X plus h equals 15. That's what the English sentence translates into. Okay, must translate from English into math equation. Is that clear? Okay, can. Then express the volume of the box in terms of h. H only. Sorry, x. In terms of x only. The one, the h. So what's the volume? V. Let V cm cube be the volume of the box. Sorry, I didn't write that down. So what's the formula? Hello.
The formula. X square h.
Yes. But you want in terms of?
You want in terms of x.
Then what do you do to the first equation?
What you do in the first equation, you make the x the subject, so x equals to 15 minus h.
Are you sure? You want to keep the x? If you make x the subject, you're gonna stop in.
I mean, you make h the
subject.
Yeah.
Okay, so 15 minus x instead would be better. Is that clear? So that you can replace the h. Keep the x. Replace the h. So h now becomes 15 minus x. Clear?
Yeah.
Okay, now then let's just expand this. 15x squared minus x cubed. Okay, good. First part answered. Use this expression to determine the maximum volume of the box. I'll just go through this question. So standard procedure again is testa or second derivative test. So dv by dx, what do you get? 15 times 2, 30x minus 3x squared. What do you do next? For
For SP, set dv dx equals to 0.
Which implies this minus this equals 0. I can factor out 3x. I get 10 minus x equals 0. So x equals to 0 or x equals to 10. Can x be equal to 0?
Can x be equal to 0? No, because it's a length.
Yeah, length is positive. So that means x equal to 10 only. Then what do we want? We want to find the maximum volume of the box. So do we sub in into the original v or the dv by dx?
Sub into the v.
Into v, exactly. If you sub in into dv by dx, what will you get?
If you sub it into dv over dx, you get 0, no?
Yes,
You get
exactly.
0.
You'll get back 0, right? It doesn't make sense, right? Of course, because we started with 0, we get 10. Then we sub back in, of course, we'll get back to 0. Don't sub back into dv by dx. That's a common mistake made by students. Then they get confused. Why 0? Some students even better. Somehow they type in a calculator, instead of typing a 3, they type a 8 or something. Then they get something that's not 0. So they sub into the wrong equation, they type in a calculator wrongly, they get an answer that's not 0. Then I'm like, how to help you? Okay. But please take note, sub in into the original v. Can? So v equals to 15 times 10 squared minus 10 power 3. Okay, I need a calculator for this. So 15 times 10 squared minus 10 power 3. Then 500 is the volume. cm cube, I think. Yeah, in cm. So cm cube. How to show that it is a maximum? You need to do the. What do you need to do? How do you know for sure this is maximum? Sorry, I should show you the question. Use this expression to determine the maximum volume of the box.
Okay. Maximum volume of the box.
We found the volume, and of course, by context, we know it must be maximum, but you need to prove that it is a maximum. What are you supposed to do?
Oh my.
E S D
S D A.
TA, which is table, our second derivative test, right?
Second derivative test.
Yes. So how?
Differentiate 30x minus 3x squared, which is just 30
d
minus
over
6x.
d what? Tell me the expression. D what over d what?
Dx over d wait, oh my god, d2y. Oh,
Why?
d, no, d2
Must learn how to read
over
it.
dx
square. D2v over dx squared. Yes, equals. So you differentiate 30 minus 6x.
Yeah. Sub 10 into that. Then you get negative 30. So means less than 0, which means it's maximum point.
What is maximum?
I mean, volume is maximum.
V is max. Okay. Maximum point, or usually what, when you want to determine nature of stationary point, what you will say is that 10 comma V, right? So 500 is maximum point. But if you draw a graph, what this really means is that, what's the formula for volume? X squared 15 minus x. Okay, so there's a 0 here, there's a 15 here. It probably looks something like this. Not too clear. What this is, oh wait, let me read again. 15x squared minus x cubed. Oh, it's the other way around, sorry. Let's see. Wait, how does the graph look? You need this shape. Right, right. Okay, this is probably how the graph of the volume formula looks like. This is V equals 15x squared minus x cubed, which can be factorized as, what was it? X squared 15 minus x. Right? Oh, sorry, not y, V. Okay? Then what is really going on is you found this point here, 10, 500. That's a maximum, right? It's the highest point. But here, when we are doing application question, you need to answer the question, which is to show that V is a maximum, the volume is a maximum. So just say V is maximum. But of course, we all know V is referring to the 500 here. Okay? Don't need to say V equal 500. Just say V is maximum. It's the most efficient way to say it. Okay?
Yeah.
Max. Very good. Moving on. Spheres. Is there anything more difficult? Let me see. Wire, man standing, a cone inside a sphere. Hey, let's try this. 15. Okay, let's take a look. Wow, so scary. Red color one. Whatever. Okay, a right circular cone of base radius r cm and a height h cm fits exactly into a sphere of internal radius 12 cm. Okay. Then take note that the radius of the right circular cone is r cm. This internal radius 12 cm is referring to the radius of the sphere, not the cone's circular base. Okay, r is not equal to 12. This guy is radius of circular base of cone. The 12 is radius of sphere. Part 1, express r in terms of h.
Express r in terms of h. What the? Express r in terms of h. But
So
you
here
say the
you need
radius
to
is for the sphere.
So here you really need to draw a picture. For this sphere, what's going on is that the cone is sitting entirely inside. So let me just try and replicate the drawing. Okay, you need to see a pattern. The center of the sphere is actually over here, right?
Yeah.
So that means that from the center, all of these lengths are radius r. I mean, sorry, length 12. Sorry, it's a 12. Yes, very good. So that length there over from here to here is 12. Okay. Okay, sorry, I shouldn't draw solid line. I should draw broken line because it's not part of the sphere. Okay, good. Then this is, of course, the remaining part here must be what length? This was
less
h, right?
than.
This must be
h minus 12.
very good. H minus 12. Then let's look at the diagram. Oh, we know that this. Okay, let me try. I'll just use the same color. This part here is R, right? Can see R. Then can you see a hidden right angled triangle if you just draw a line from here to here? Can you see? But wait, what is this length?
Pythagoras.
No. What is this length?
Oh, what is
That's
that
the
length?
center of the sphere. This is a corner of the cone.
This is 12.
Yes, it is.
R squared plus h minus 12 squared equals to 12.
The most difficult, everybody knows Pythagoras theorem. The most difficult part here is to identify this is 12 and this is h minus 12. Is it okay?
Yeah.
The rest is easy, right? Pythagoras theorem. Sec 2 kid know how to do. Right? Sec 2 kid know how to do. 14 years old. You learn Pythagoras theorem. Some 13 years old learn already. Some primary school learn already. So that's easy. The more difficult part here is you need to be able to draw the diagram and figure out, oh, this one H, this one 12, this is H minus 12. Okay, maybe after you see the answer is simple, but when you do it on your own, it's a bit tough. Okay, you need to practice, then you will get good. So anyways, now that you have identified the right angle triangle, Pythagoras theorem, let's just go. Okay, so H minus 12 plus bracket square plus R square equals to 12 square. What did they ask for? Express R in terms of H. Okay, so I need to make R the subject. So R square. So 12 square minus bracket H minus 12 square. Expand. I'll leave the 12 square alone. Minus away bracket H square minus 2 times H times 12 plus 12 square. Bring the minus in. 12 square minus H square plus 2 times H times 12 minus 12 square. What happens? 12 square cancels away. 12 square is 144. Not important. So minus H square remains. 2 times 12 is 24H. R square equals to minus H square plus 24H. To make it look nicer, I can write as 24H minus H square. Then I want to solve for R. What do? Take the plus minus square root, right? So 24H minus H square. But can R be negative?
Can R be negative?
R
No.
for radius. So therefore you reject. Okay, I'm just gonna put down positive and reject negative square root 24H minus H square. Sorry, make it look neater. Reject R equals this guy, since R is radius, which is more than 0. Okay, good. So now we have found our formula for R, square root 24H minus H square. Part 1 complete. Part 2, let's go. If the volume of the cone is V cm cubed, show that V equals blah, blah, blah. How? Formula for volume of cone, remember?
Volume of cone.
Just like pyramid.
1/3 pi R square H.
Yes, very good. Correct.
Equal to 1/3 pi. Then
what they want? Look at the equation on the right side. What letter do you see?
They want it in terms of H.
Good.
So
what did they ask you to do in part 1?
they express R in terms of H.
There we go. I got square root 24H minus H square.
Yeah. Then so I just put R square. 24H minus H square.
Very good. Square the square root, no more. So you're just left with 24H minus H square times H. Then just expand and you will get 8 pi H square minus 1/3 pi H cube. Okay, let's just do it. So 1/3 pi, leave it alone. Multiply the H in 24H square minus H cube. Now 1/3 pi times 24H square. 1/3 pi times 24H square, write down first. Minus 1/3 pi times H cube. 24 divided by 3 is 8, right? 24 divided by 3 is 8. So it's just 8 pi H square. Minus, this one I write it as, let me see what they did. 1/3 pi H cube, which is the same lah, huh? Convinced? Oh no. Is it okay? Shown. Good. Part 3. Let's go.
Find the value of R, of which V has a stationary value, and determine whether this value of V is a maximum or minimum. Hence, find this volume.
You realize the question is always the same lah. Let's start.
Okay.
Okay. Oh, sorry. I shouldn't put V cone. I should just say V. Okay. Carry on. I want to try.
dV over dH equals to 16 pi h minus pi h square. Okay. Then set dv, for SP, set dv over dh equals to 0.
Good.
Okay. Then you get
this expression equals 0.
Equals 0. Then
Factorize.
yeah, okay. You can take out the h, then
Anything else to take out?
and you can also take out the pi. Yeah.
Pi h.
Yeah. Then 16 minus h equals 0. So therefore h equals 0 or h equals 16.
Very good.
So you have 2 points. H equals 0 reject as length. So yeah. Then sub h equals 16 into the sub h equals, yeah, the first one, the one you highlight, volume. Yeah. Then
just
you
do
get
that quickly.
Yeah.
Let's leave it in terms of pi. So we get 8 bracket 16 square minus 1/3 16 cube. Okay, can you help me to type this in a calculator?
I get 816.
Did you know you can download a calculator on your iPad?
iPad? Wait, that's from your iPad?
Yeah.
Huh? Wait, how?
I think the app is called NCalc. NCALC.
Free?
Free.
Oh.
You download and then you get two. They will force you to get two calculators in that one app. I use this Calc84, I think, if that's the name. Yeah. Can slide it. You can. I mean, how do you do it? I think. I forgot how I set this up already. You have to like click. Oh no. Like the Calc84 is on the right corner. You open. You have to slide up, and the Calc84 you slide up like this. Not now. Yeah. I think so. Hey, is it Calc84? Maybe it's not Calc84. It's not. I don't know. But anyways, what's the value? Go and figure out later.
Do you get
Was it 2048?
2048 over 3?
Yes. Okay, I did manually. Okay, yes, good. Ken. That's the answer. Oh, by the way, usually your answer is expected to leave in exact terms in terms of pi. Okay.
Okay.
Ken, good. So yeah, not enough. This one, how do you know if it's maximum, minimum, or inflection point?
How do you know it's okay, you just sub into the V.
Huh?
Wait, hold on. Wait, I mean what I mean
E solve as
differentiate the
S
d2v over dh square
correct. Good.
equals to 16 pi minus 2 pi h.
Good.
Then sub h equals 16 into that.
The more efficient way is to write this down and then what do you draw?
The line, then
Line
h
equals. What
yeah.
is it? What value?
16.
16. Very good. So I will substitute the h with 16. So I get you see This one, how many pies are there? 16. This one, minus away 2 copies of 16 pi. You can think of this as 1 apple minus 2 apples, where apple is 16 pi. How many apples left?
How many apples left?
One minus 2, how many?
-1.
So you get -1 apples, but apple is 16 pi. But clearly, you don't need a calculator. Pi is positive, 16 is positive, so whole thing is positive. -1 times positive is
Negative.
less than 0. Don't need calculator. Can
Okay. Yeah.
okay. So therefore,
Max point.
apply. What is max?
Max volume.
Volume. No. What thing is max volume? The H, the V, the dV.
The V.
The V is max. Okay. Oh, sorry. Oh, wait, max volume. Okay, same thing. Usually phrase it as V is max. Max volume, same thing. Okay, Ken, good. So if you can do a rate question, you can do the rest already. Okay, time to introduce a new. Okay, the rest of the questions will be your homework. I will also assign you more questions from the other textbook so you can have more practice, because this is one of the most important topics you need to practice. How to convert from English into picture, picture into formula, formula, Desta. Clear?
Okay.
English, picture, formula, Desta. Let me write it down. That's essentially all we are doing today so far. English, story, convert into a picture. Then you must bring in your mensuration knowledge, volume of a cone, that kind of thing. Then you will get an equation in one variable. So like, for example, just now the x squared h, you need to replace the h with something so that it's only in terms of x, in one variable only, on the right side. Right hand side, only one variable. Right hand side, only one variable. Only. So you can proceed to do Desta or do second derivative test faster. This TA and the second, these two, the purpose is to show whatever the thing you're trying to optimize, show it is a max or a min. It is the objective. What do I mean by objective? I mean, for example, in this case, the objective is to maximize the volume. So V, the volume, is the objective. We call that the objective function. Let me write it down. Objective function without constraints. Without constraints. What's a constraint? Out of topic already, but out of syllabus already. But in the future, you'll learn more about different techniques to optimize functions, such as, let me just write down some of the funny names you'll hear. The Lagrangian. Lagrangian. Learn about.
What the hell?
It's topic related university content already. Partial derivatives. Okay.
What the hell?
Not full. Currently, you do d by dx. Later, you'll learn a curvy d. This is partial derivative. You'll learn more about it in university if you are going. Then what else is there? There's also what is there? Linear programming. This one, linear programming. It's an interesting topic. You can go learn about it. Then it's, the more general topic is, what is it called? Convex optimization. Oh, if you learn about this, you learn beyond me already. Convex optimization, never learned before. Linear programming is like just 2 chapters of this of this subject, just 2 chapters in the textbook. Okay, never mind. Don't need to know. Moving on, we learn the basic stuff first. Okay, now I need to introduce to you transcendental functions. Huh? What's transcendental functions? You already know lah. LIATE, I already introduced just now. We're gonna focus on this, and this. This one, complete. We already learned all the techniques, right? So far, what are the techniques for differentiation? Sum rule. Sum rule is do the derivative term by term, plus and minus separate out, and you can factor out coefficient. For example, derivative of 2x power negative 2 minus 7x power 5 plus 6x power 2. This is just 2 times the derivative of x power negative 2 minus 7 times of derivative of x power 5 plus 6 times derivative of x squared. Okay, then after that, how do you differentiate x power negative 2? Bring down the old power, multiply by the base, minus 1 to get the new power. Bring down the old power, multiply, minus 1 to get the new power. So on and so forth. This is known as the power rule. Right? Just a recap only. More generally, differentiate x power n equals n times x power n minus 1. Okay, next one. Sometimes the functions look like this. A function inside a function. We call this a composite function. What rule do you need to use?
What function?
Also known as a chain function. Chain together. Right, like a chain. Chain function need to use what rule?
Chain rule.
Chain rule. Chain rule. Chain rule. Differentiate the outside, keep the inside, multiply by derivative of the inside. What do I mean? For example, if you have, let me think of a good example, x power negative 2 plus 3x cubed. Oh yeah, the one, so many 3's. Power 4 to the power of half. I want to differentiate this. How? Can you see that there's a outer function, something power half, and there's an inner function inside? So differentiate, what do you get? Bring down the old power, copy the base, minus 1 to get the new power. Do it in your head, half minus 1, negative half. Copy the base, so whatever was in between the brackets, copy and paste. Then you multiply by the derivative of the inside, which is the derivative of the inside.
2x minus 2x to the power of minus 3 plus 12x to the power of 3.
Very good. Yes, that's chain rule. Okay, just recap. And then of course, after that, if you got multiplication going on, product rule. If you got division going on, you use quotient. Do you need me to go through?
No.
Fg prime equal f prime g plus fg prime. This one quotient rule is f over g, you differentiate, you get low d, high less, high d, low, draw the line and square below. Okay, bottom d top minus top d bottom, whole thing divided by bottom square. Product rule is take one, differentiate other, plus take the other, differentiate one. Okay, good. You know these techniques for algebraic expressions. Now we focus on the transcendental functions. I is out the picture because that's a bit too complicated. We only deal with it in H2. So the first one I'm gonna deal with is logarithm. So just LTE, LTE. L for logarithmic. So if you have if you have ln of x, y equals ln of x. You need to memorize this for me. Dy by dx is equals to 1 over x. That's this one assuming x is more than 0. Is that okay? Can Good.
Yeah.
So memorize it. But what if I upgrade now to y equals to ln of 3x plus 7? Then what is dy by dx? It will be 1 over whatever was in between the brackets. So 3x plus 7. Right, just now I also did 1 over whatever was in between the brackets. Take note, logarithm, they don't usually put the brackets here. So I'm going to remove the brackets. Okay, maybe I'll leave the bracket in, but I scratch it off to remind you that usually they won't put the brackets. I put the brackets there to remind you, okay, just take whatever is in between the brackets, put it at the bottom. Take whatever's in between the brackets, put it at the bottom. Or when it's 2 or more terms, they'll put brackets, so it's easier. Not enough, because this is a composite function. Ln is an outer function, 3x plus 7 is an inner function. Think of it like this is f of x equals ln x, g of x equals 3x plus 7. So this is actually f of g of x. Can you see that?
Yeah.
Outer and inner. So chain function, need to use chain rule. Chain rule means whatever was inside, you need to differentiate it. Whatever was inside, need to differentiate it, a g of x. Differentiate, you get 3. Then that's your final answer. You can rewrite it nicely as 3 over 3x plus 7. Okay, that's logarithmic. Of course, it can get more ugly inside, but you know what to do, right? Just differentiate. Let me give another example. Let's say y equals to ln of 3x power negative 1 plus 2x power 7. So dy by dx equals to
dy dx equals to 1 over 3x
copy paste.
to the power minus 1 plus 2x to the power 7. Then differentiate inside the basket.
Times first, then differentiate inside. What is it?
Minus 3x to the power minus 2 plus 14x 6 x to the power 6.
Yes, very good. And of course, this one can go onto the numerator, right? Because this is like over 1. So fraction times fraction, just multiply 1 times this, 1 times this. So it's essentially bringing this guy up to the numerator. Okay, can good. Let's move on. Logarithmic done. Now we go on to trigo. Trigo, you also need to memorize this for me. Please remember this square for me. Differentiate the sine x, you will get cosine x. So the symbol to do that is d by dx like this. Can? Then if you continue differentiating, differentiate cosine x, it becomes a negative sine x. And that is all you need to remember. Okay, actually I should write it down separately. Differentiate sine x is cosine x. Differentiate cosine x, unfortunately, is a bit naughtier. It has an extra minus sign, negative sine x. Remember how sine a plus b equals to what? Sine a cos b plus cos a sine b. Remember this?
Yeah.
Then how about cosine a plus b?
Sine
Cosine. Wrong.
Cosine a sine.
Wrong.
Cosine a cosine b.
Correct.
Plus sine a sine
Wrong.
b. Minus sine a sine b.
Yes. Finally. So what you need to remember is this formula. The plus sign here becomes a minus. So cosine behaves a bit rebelliously, a bit more rebellious. Plus, they don't want, you change into a minus. Same thing over here for cosine. I'm sorry, you need to memorize this. Cosine, you differentiate, you end up with an extra minus in front. Can? For sine, it's a bit more well-behaved. Plus stays as plus. Positive signs, positive cosine. Positive, positive. Can understand this analogy? No choice, sorry, you need to memorize one. Can? With this, I'm gonna rewrite it as a square. So differentiate sine, you get cosine. Differentiate it again, you get negative sine, right? So far, okay? But now let's say you try to differentiate negative sine. What do you get? Well, what's negative sine? It's really just -1 multiplied by a sine, right? Which is a coefficient.
Cosine become negative cosine.
Very good. So it becomes negative cosine. Then now if you try to differentiate negative cosine,
Sine x.
Differentiate cosine, you get negative sine, but minus minus becomes a plus. So you go back to sine. Okay, just to make things a bit neater, I'll just write the d by dx in the middle, so I don't have to write it 4 times. Is that okay? Is this called a commutative diagram? I don't know. I never studied abstract algebra. Okay, so anyways, this is just a nice little diagram to tell you that they go in a cycle. Sine goes to cosine, cosine goes to negative sine, then goes to negative cosine, and goes back to sine. So can you imagine what happens if you take the, sorry, I need more space. I should have brought it down. What happens if I take the derivative of sine of x, but no, I don't want the first derivative. I want d5 sine x by dx5. Oops. Wow, x power x. Wow, cannot. Too crazy already. This one. What is this? It means you differentiate sine 5 times.
5 times cosine x.
Very good. Oh, you can see a pattern. Yes. So it means that you differentiate first time, then differentiate 4 times inside. This one, differentiate 4 times, what happens? Let's count. Differentiate 1. Actually, you know what? 5 times can count 1 by 1. Start from sine. So 1, 2, 3, 4, and 5. You go back cosine. Okay? Or you think of it as differentiate 4 times, you get back to the same thing. So this is sine x again. Then d by dx 1 time outside. Differentiate sine, you get cosine. Okay? Interesting? Just a tidbit, extra only. Not important. They won't test something so difficult. To ask you see the pattern. Wow, 5th derivative of sine x. Changes to 500. Then what is the answer? No, they won't test you on that. Maybe in competition math, they'll test you on that. But yeah, you're not doing competition math. Let's just do something a bit more simpler. Like let's say if I now have sine of the logarithm of x. How to solve? Oh, very simple. You just treat the outer function as sine, inner function as ln of x. So, oh, by the way, I mentioned logarithm, but specifically only base e. If you have other bases, sorry, I should have gave more examples. Let me just write them down. This is 1, this is 2, this is 3. Let me give you another example. If let's say the logarithm base is different, it's log x, must have an x, okay? If no x, then we can't differentiate. It's not a function, it's just a constant. Differentiate constant, you get 0. Let's say this is not e is 5. How to continue? Take note, dy by dx is not simply 1 over x anymore. Not that simple. Whenever the base is no longer a e. Okay? So what you need to do is you have to rewrite it. So do you agree that 5 power y will be equal to x? Bring the 5 over. Can. So now what we can do next is we can take ln on both sides. Log base e. Can?
Yeah.
Okay, so far? Now power rule, y can bring down, right? So it becomes y times ln5. Is that okay?
Okay.
Then from there, you can make y the subject again. So we end up with 1 over ln5 times lnx. That's just a change of base formula. If you remember your change of base formula. Can you remember? Change to base e. Forget? Go recap already. Okay, I'm just gonna move on. So now that we have this 1 over ln5, type in a calculator quickly and what do you get? Okay, I have a calculator, I can just demonstrate here. So 1 divided by ln of 5. Oh, what do you get? Oh, 0.6213. Okay, interesting, cool. So it's just some number, 0.621 lnx. What happens when you have a number in front and you want to differentiate?
You have a number in front and you want to differentiate.
A
Just when you
factor,
have a,
right? I got a number in front. Like differentiate 7x power 3. What do you do with the 7?
when
Just
bring
factor out, right? Factor out. Then after that, you differentiate 3x squared, 3 times 7. But 21. But of course, here there's a coefficient. Just leave it alone. Just leave it alone. Then you multiply by derivative of ln x, right? Which is, I'll write it down first since we're still starting. Which is, forget already. Differentiate ln x, you get 1 over x.
1 over x.
Must remember. Okay. Maybe I should have started this earlier. Okay, 1 over x. Yes. But of course, this is not actually 0.621, right? It's not actually 0.621. The exact value, this is only an approximation. I want the exact value. So it's actually 1 over ln5. 1 over ln5. Okay? And that's your answer. 1 over ln5 bracket x. Take note, you must put a bracket. You don't go and put, if you don't put the brackets, I may accidentally read it as 5x, then you take the logarithm of the whole thing, which is wrong. Okay? Clear? Very good. So put brackets around the ln5. That is how you deal with logarithms of non-natural logarithms when it's not log base e. This is a bit of a pathological example, an extreme example that's unlikely to come out. Usually, not always. Sometimes it will come out, but usually we'll only deal with natural logarithm. Okay, good. Now let's go back to the example. How to differentiate sine of ln x. Differentiate sine, you get cosine. Differentiate cosine, get negative sine. So here we're dealing with the original sine. Differentiate sine, you get
cosine.
Okay, so you write down cosine first. But there's another function inside. What do you do inside the bracket?
1 over x.
Wrong. You copy and paste first. This is what rule?
Chain rule.
Chain rule. Fx is, the outer function is sine x. The inner function gx is ln x. So this guy is actually just f of g of x. When you differentiate, you f prime the outside first. The outer function you differentiate first. The inside gx keep the same. Then you multiply by derivative of the inside. So what is different? Then after that, you differentiate the inside ln x, which will give you that 1 over x. So the 1 over x is outside. I mean, sorry, it's only done afterwards. You must keep the inner function inside at least one time. Is it clear? Okay, so this is actually just cosine bracket ln x all over x. Okay, very good. Now you have sine. How about if we take cosine of a sine of x? Okay, am I drawing the correct number of brackets? Let me count. 1, 2, 3 left brackets. 1, 2, 3 right brackets. Okay, correct. Balance out. What is this derivative?
Minus sine.
Okay, minus sine.
The bracket
What's inside?
open. Sine x.
Copy and paste it. Okay. Times.
Times.
Chain rule. You have differentiated the outer function. Now you deal with the inner function.
Minus cos. Wait.
Correct.
Cosine minus cosine x.
Hey, sorry. No minus. Wrong.
Sine x.
That's wrong. This one. Differentiate sine, you get cosine. Sorry. Yeah, you're right. Yes, it's cosine. Don't have minus. Okay, good. So take note, sine and sine is not the same as sine square, okay? It is not negative sine square of x. Different, okay? What is sine square x? Sine square x is, you know from trigo, it's sine of x multiplied by sine of x, okay? Here, this is composition of functions, sine of x. So just to do a quick example, let's say you set x equals to 10 degrees. Then sine of 10 degrees. Let me just show you. Maybe I need to do it at the left side. I can move my calculator, right? Sine of 1 degree mode. Okay, deg is degree. Sine of sine 10 is what? Approximately 0.00303, right? But if you take sine square of 10 degrees, this is really just sine of 10 degrees like this one time and then bracket square outside. So I'll do that. Sine of 10 degrees, then to the power of 2. This is 0.03015. Are they the same? Yes or no? Different, right? Clearly different, huh?
Yeah.
Okay, good. So composition of sine is different from square of sine. Please take note of that. Okay, moving on. Yeah, so this is your final answer. That's it. Don't need to simplify. That's it. You cannot simplify. All right? Can? Good. One more function I forgot. Sorry. One more line also need to memorize is tangent. This one, differentiate tangent, what do you get? It's secant square x. Okay, secant square is what? 1 over cosine square. Okay, please remember this for me. Differentiate tangent x, you get secant square. Differentiate tangent, you get secant square. Differentiate tangent, you get secant square. Differentiate tangent, you get secant square. Memorize already? Differentiate sine, you get cosine. Differentiate cosine, very naughty, extra minus sign. Just opposite, sine, cosine, cosine, sine. Now differentiate tangent, you get secant square. Okay, now repeat for me. What is it?
Oh my god. Sine, cosine, negative sine, tangent. Tangent is sine over cosine. So
You could use quotient rule to derive. But I need you to memorize for me. Sorry, secant square x. Okay, still a bit iffy. Sorry, I just introduced only. Yeah, you gotta memorize this. Let me show you why is it secant square? I actually asked you this once of many weeks ago, around 1 month ago, to as a challenge to get you to try this on your own. But let me just show you now why derivative of tangent x is secant square. You know it is sine x over cosine x, so it's a quotient, right? Then if you want to differentiate a quotient, what rule do you use?
low D, high, less, high D, low, and draw a third line and square below.
Very good. So now that you know differentiate sine and cosine, let's try this. So low means cosine x, bracket, times D high. So differentiate sine, you get cosine. Okay, maybe I write the working first. D sine x. Low D high, I don't need this bracket. Less means minus, high means sine x, then times, sorry, I'll put bracket here, D low. Draw the fraction line, square below, so cosine square x. This is not cosine of cosine x, this is literally cosine square x, cosine x times cosine x. Okay, let's differentiate the sine x. What do we get? Oh, it's a cosine x. Can? Clear? Then minus sine x. Derivative of cosine is?
Minus sine square.
Minus sine. Then after that,
minus sine x.
let me just try and squeeze everything on the same page so I don't need to move up and down. Give me a second to modify this. Okay, so sorry, what was it? Negative sine x, and then because negative times negative become positive, so positive sine square, right? Is that what you're saying? And the left side is just cosine square, so minus minus become plus, so sine square. But what is cosine square plus sine square? Forget already? Oh no.
No,
can you remember?
Is 1.
It's 1. Oh, nice. So 1 over cosine
so
square.
So becomes secant square.
Secant square. Yes. Okay. Memorize, I strongly recommend that you memorize this. Differentiate tangent, you get secant square. Please, because the next topic we're gonna be learning is integration. Integration is just, I'll review the surprise. It's just the reverse of differentiation. You're gonna learn how to work backwards. And you have no choice but to memorize. It's a lesson in pattern recognition. Integrate secant square x, the answer is tangent x. Why? The reason is because differentiate tangent, you get secant square. Just because. The reason is in university, called the fundamental theorem of calculus, part 1 and part 2. I'm not going to talk about it. You don't have enough prerequisite knowledge to understand it fully. Just help me to memorize this, okay? Can? I show you the reasoning already. Not incomplete. Why is derivative of sine x cosine x? Why is derivative of cosine x negative sine x? You need to learn about limits and the full definition of the derivative before you can understand. So for now, I need your help. Please help me to memorize. Can? If not, you cannot follow along already. Very serious. Can memorize this tree? Okay, your homework. Okay, moving on. Trigo is done. Should I give more examples? Yes, I should give more examples. Let me give more examples then. Okay, let me just put this down at a corner. I should just always put this down at a corner. And then I'll continue. So now, example, where am I already? Example, and you label my numbers. This is 1, this is 2, this is 3, this is another, I guess this is 4, this is 5. Okay, let's take a look at another example. What's good? What function you want?
What function?
Okay, I'll start you off. Tangent x to the power of 5 plus logarithm of, I don't know, x to the power of 3 minus sine of L at x. Hey, swap it around, why not? A ln of sine of x.
My God.
Okay, let's try this. All in one.
Okay.
Let's make your life more difficult with more negative signs. I'll introduce a cosine instead. Should I make your life more difficult? I'll put a square here. Okay. Can one, you know how to handle this. Maybe I should just put the square bracket notation. Round bracket, square bracket, then curly brace. Okay. Can. Carry on. Go.
Okay. 5 tangent x. Wait. Hold on. That's not quite ready. Wait,
correct.
is it?
It correct? It's correct.
Times. To the power of 4.
Yes.
Times secant square x.
Good. That's the
plus,
first term complete. Plus.
Oh my God. Oh, I know it's 1 over x, but
okay. So just 1 over
1 over x cubed minus ln bracket cosines x squared.
ln of cosine of x squared. Yeah, that's how you read it. Okay, ln of cosine of x.
Okay, ln of cosine.
Okay, just to save space, I put a plus sign in the line below. Times
3x squared minus 1 over cosine of x of square.
Just x squared.
Okay. Bracket close.
Close bracket. So you have differentiated the second term. But is it complete?
No.
You only dealt with the ln, 1 over.
Yeah.
How about this guy?
Then
Chain rule again.
Yeah, then times the minus sine. Oh my God. Minus 2 sine x.
Wrong. Hey, wait. What's inside the sign first? Differentiate cosine, you get negative sign, but what's in between the brackets?
X squared.
Very good. Keep the same. Chain rule. Keep the same. Layer by layer. Then after that, times, what was it? What were you saying?
Times 2.
Huh? 2 only? Go
Wait,
one layer deeper. See?
times 2x.
Cosine become negative sign. Keep the inside the same. X squared becomes
Times
2x.
2x.
Very good. Then close the bracket. That's your final answer. Well done.
What the
Very
hell?
good. Okay, but be careful here because there's a negative. You need an extra pair of brackets. So at this point, I just give up on the round bracket, then square bracket, then curly brace notation. Just use round bracket all the way. Oh, up to you. Up to you. I'm okay with just round brackets all the way. Yeah, so just leave this as the final answer. Please don't try to simplify. You simplify, I cannot understand what you're doing. Okay? Don't simplify. Good?
Yeah.
Okay. Hey, but just for fun, let's deal with this part over here. Let's try and simplify. Any special things we can see? Because you're very good at trigonometry. So negative times negative gives you positive. So let's put a plus sign there. These guys are on the numerator. So it's sine bracket x squared times 2x, all divided by cosine of x squared.
Yeah, I see. You have sine over cosine.
Very good, which is actually the same as
多
tangent
x.
x squared times 2x. Hey, interesting. Ln of cosine becomes tangent. Ln of cosine becomes tangent. It's actually a standard identity. But don't need to know. You know how to do the chain rule and give me this as the answer. That is more important. Clear? All these, it's a tangent after differentiating ln cosine. It's just a coincidence. You already know how to derive on your own. Don't memorize this kind of things. What I need is these 4 things. Actually, not enough. Still got one more. Not done yet. LTE not done yet. This is L. This is T. Still got. What's the last one? E. What does E stand for?
Exponential.
Yes, exponential. This one is the easiest one. Wow, my favorite. You know why or not? Let's go to number 3. This is exponential. So exponential is referring to base E, not the general like say 3 power x. No. This one no. Later. I'll give it as an example. So first one you need to remember is if y is equals e power x, dy by dx, which is rate of change of this function, is the same thing. It's the same thing. Okay?
Wait, what do you mean?
Means you just copy and paste. Like previously, differentiate sign, you get cosine. Differentiate cosine, you get negative sign. It will change, right? It will change. Sometimes got plus, sometimes got minus. But for e power x is a very, 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 very extremely special function. You differentiate it, you get back the same thing. It is unique. It exists, it is unique. It is the only function that has this property of its derivative being the same as its original function. It's the only one. That's what makes it special. Okay? So let's just get some intuition behind what this means. So the e power x graph looks like the following, roughly. 0, 1 standard. Y equals e power x. Don't remember, go recap. I have recorded videos of this. Why is it 0, 1? Start in x equals 0. That one. Horizontal asymptote at x-axis. Right? Yes? Can remember? Roughly, just look at the graph and you can believe. So let's say that this point here is 1, what's the coordinates? Sub in x equal to 1. So e power 1 is just e. Then you draw a tangent line here. So line means what? L, y equals mx plus c. How do you find the m? How do you find the c? M is just dy by dx, but sub in x equal to 1, right? But what is dy by dx? It's e power x, and sub in x equal to 1. So it's just e power 1, which is e. Okay, 2.71828 approximately. 1828. Dot. Okay, whatever. Doesn't matter. It's just a constant. It's okay, but it's a very interesting constant. whatever, just move on. So m equals to e. So that means this is e times x plus a constant. So what's a constant? How to find a constant? Sub. I'm just going to use the e math style. Sub in x comma y. So we end up with e equals to e times x plus constant, which is, sorry, forgot to sub the x, times 1 plus a constant. So this means that constant must be 0, right?
Yeah.
This means that you have y equals e times x plus 0, which is e times x. Okay? That's the equation of the line. I'll just write it as y equals e times x. Okay? So the graph actually cuts through the origin. Let me show you the picture. So, oh, where's my decimals? Yeah. So you can graph e power x, if I can find the letter e first, e to the power of x. Then we can draw in y equals, what's this, ex, right? Ex, e times x. E is treated as a constant in decimals. Let's take a look. So this is the graph, okay? The more professional looking one. There's a intersection here, 1, 2.718. That's 1, e. All right? That's 1, e. Then this is the graph of the e power x, and there is the equation of that tangent line. So what you realize is that the y coordinate is 2.718, but the gradient of this line is also the same as the y coordinate. Is that clear to you?
Okay.
Did that make sense? Okay, so y equals e power x, dy by dx is also e power x, which basically means, y coordinate e power x is the same as the gradient of tangent. Just a very special function that happens to have this property. Okay, now we move on to more examples. Is that okay?
Yeah.
Then let's go on to another example. Let's try an example like y equals e to the power of x cubed plus 2x. What would this be equal to? Chain rule again. So if you have e power something, very simple. My favorite function, just copy and paste. Then don't forget chain rule. You need to differentiate the inside. So bracket 3x squared plus 2. Okay? Done. That's it. Don't bother distributing the e power something. If you want, you would have to write it as 3x squared times e to the power of x cubed plus 2x, and make sure the x cubed plus 2x is a superscript. Then, plus 2 times e to the power of x cubed plus 2x. Okay? Okay. Don't need to expand. This is good enough. Next example, let's say we have y equals to sine of e power x. What is this equal to? I mean dy by dx.
Cosine dx
Times,
differentiate ex.
which is just ex.
Ex.
That's it. Done. That's all. Easy, right? Okay. There's a lot of rules to remember. Maybe I should write this down. Let me write this down quickly and bring it with me as I continue giving examples. Copy this guy. Wait, no. This guy, right. Okay. So now that we have learned all of the functions already, it's time to mix everything up. All right, let's try one complicated example. What function would you like? Design your own function.
ln x and
Ln x. Okay. Let's say I have ln of tangent of x minus e to the power of sine x. Should I plus? Oh, plus 7x squared. Make your life difficult only. Plus, what else you want? How about tangent of sine of x?
Okay.
Did I miss anything? Let me see. Sine of e power x. Okay. Actually, we covered that already, right? So you can recycle the information. Okay, let's go. dy by dx. Wow, so complicated. Not enough space. So ln, differentiate, what do you get? It's on the right side. I need more space. Let me start a new page. Okay.
1 over.
1 over, very good. So you get 1 over what?
1 over tangent x.
Very good. It's not x, it's tangent x. And times? Since this is no longer a single x, you need to chain rule. Differentiate the inner function. Tangent x you get? Differentiate tangent x?
Tangent x secant square x.
Very good. First term complete. Next term, second term. Minus sign.
Minus sine
E to the power of sine x plus 7x squared.
Yeah, minus sine x.
Wrong. E power something stays as e power something. So all you need to do is to
minus e power sine x plus 7x squared.
Yeah. All right.
Plus
or times.
Times sine
Bracket.
sine x plus 7x squared.
Wrong. No. This is e power x. It stays the same, but the x got replaced with an inner function. Oh, think of e to the sine x plus 7x squared as a composite function. This is f of g of x, where f of x is e power x, g of x is sine x plus 7x squared. Can you see
G
it?
of x is sine x plus 7x squared.
Yes.
So
X.
differentiate sine x plus 7x squared.
Correct. Which is?
So minus cosine x.
Wrong. No minus.
Cosine x plus 14x.
Very good. Then close the bracket.
Plus tangent become secant square x.
X. Is it x? No.
No, you just put the yeah.
Yeah, put whatever is in between the brackets. Sine of e power x. Okay. Times.
Yeah. Differentiate the inside.
The inner goes
Cosine ex.
very good. Then again, chain rule, continue down the chain.
Times
Differentiate the inner again. Times
ex.
ex. Then continue down the chain. There's an x here. Differentiate. What do you get? Times differentiate x. You get?
You get 1.
You get 1. Then continue down the chain. No more already. Stop already. 2 times 1. Okay. That's how chain rule works, right? Just layer by layer, but keep the innermost. Okay.
Okay.
Hannah, now you are an expert of chain rule. Now you fully understand how to use chain rule. So complicated, you also can. Okay, clear. Very good. Now I can assign you all of the complicated questions. Let me just show you what are the questions I'm going to give you. Give me a second. Where is the file? Can you see the screen?
Yeah.
Yeah, so I'm gonna give you these kind of questions where the area, the formula you're trying to find out will involve not just X and R, it will involve all sorts of funny shapes. Hollow copper pipe. And what's the volume of the pipe? As an outer circle, as an inner circle. You need to subtract, then you can get the surface area, cross-sectional area. Sometimes you got trapeziums as well, 30-degree triangle. Oh, that reminds you of 30, 60, 90 triangle. Right, you got surds involved as well. You find area of the trapezium. What else? You got the standard cone question. You need to draw your similar triangles, R over H, 16 over 24, that kind of thing. Make R the subject, make H the subject. Only one single variable. Sometimes you got spheres. What else you have? Oh, what is this? What is this? Out of syllables. This is A levels. Yeah, separable differential equation. Oh, yo, sorry. This one extra. Skip this question.
Okay.
13 also separable differential equation. Skip this question. Yes, I will explain it if I have extra time next lesson. Try the question first. Then all answers to be exact. Oh, this one can be done. This one can be done. Question 14. But you need to think a bit. Oh, Oh wait, maybe you can't. This is this is separable differential equation. Sorry, cannot. A bit too difficult. Yeah, cannot. Nope. Then 15, sometimes you have engineers. Wow, engineer design a lifting device. They give you some funny diagram. Don't care lah. What diagram? Don't care. The main purpose, the main thing is the math behind it. There's a rhombus shape going on. Okay. Then you need to go and figure out a formula for H in terms of X. Rhombus. All your geometry skills must come out. Okay. Oh, then sometimes even more difficult. What's this? A security spotlight is situated 10 meters from a straight fence. And spotlight is rotating at a constant speed. Blah, blah, blah. Then you must read the story and figure out what all those letters and variables represent. Okay. Similar to the, so you see right angled triangles, definitely Pythagoras theorem will be involved. But this question is a bit more challenging because it involves a trigonometrical identity. You need to prove this 1 plus tangent square equals secant square before you can do the derivative. Okay, rate of change question. Okay, what else we have? Okay, all these are standard questions, blah, blah, blah. But then sometimes you'll have this kind of question. Wow, find the volume of non-standard figures. Then you got this weird shape that's designed using gold wires. You bend here, bend there, and you figure out what's the volume. Okay, sometimes you got this. Wow, what is this? Oh, it's a box that has been opened up. Question 27. I can't get it to show on one screen. Okay, yeah, square piece of cardboard paper. Then they made up of 4 isosceles triangles. You need to find the volume of the pyramid that's formed when you fold the cardboard box back up into a container, like a Toblerone or something, Toblerone container. Okay, what else we have? Some pen shape. It's a cylinder inscribed in a cone. So this is a cross section of that solid. Okay, it's actually a 3D figure, but we take a cross section, like a X-ray, something like that. You need to find the volume within the cone, but not occupied by the cylinder. Wow, so the remaining volumes at the top triangle, left triangle, and the right triangle, but more like a volume. So it's not a literal triangle, it's volume. Please take note. Just take big minus small. What else we have? Something similar you've seen before. Try again, just try again, practice. Just that the numbers change only. A cone that's inside a sphere. Okay, hidden right angled triangle we need to identify. Okay, what else? Even more weird shapes like this. Got triangle, 60 degree, 90 degree, 30, 60, 90. So you need to use your certs knowledge again. Sometimes it looks like a trapezium, got rectangle shapes going on. Then now finally, got a quadrant. Reminds you of our primary school questions, right? Finding out the area of a quadrant. just take the area of circle divided by 4. What else we have? Wow, what's this? This is a very badly drawn two isosceles triangles and a rectangle shape. Okay, go and find out the area of the rectangle or the landscape, the entire shape. Then sometimes you got, wow, what URA, they are plotting, they are doing some planning on the plot of land. What's the area of this triangle? Find the value of the angle theta that will maximize the area. Okay, what else we have? Semicircles. What else we have? Open cylindrical containers. What else we have? Finally, something interesting. 37. This question will involve theta. Okay, which will require you to remember your circle properties, the angle properties in a circle. Do you still remember? Am I still connected?
Yeah.
Angle at center equals 2 times angle at circumference. Sine rule, cosine rule. Remember?
Yeah.
Must go and recap. Area of a sector, all must come out and use in order to solve part 1. But if you cannot solve part 1, where's my part 2 and part 3? Okay, I know where it is. Okay, I need to unhide it. Yeah, then you will need to go and if you don't know how to do part 1, just skip it. Do part 2, part 3, part 4. Okay, use the formula given. Like A equals whatever, find dA by dr or dA by d theta. Can? Okay, I'll just assign this as homework. I think it's enough to give you a lot of headache. 37 questions.
Yeah.
Okay, that is all for today.
Okay.
And thank you.
Thank you.
And see you next time. I'll send you the
Okay.
talk. Bye-bye.
See you. Thank you. Bye-bye.
Bye-bye.